Yes guys, in this video we'll be solving one more a little bit complicated example that will help you. I always like to solve example in two different ways, so you will try to understand. So in this in our last video we discussed about deformation, when we say that we have a formula, we have this formula of deformation. So in this video we are still in chapter 2, so of course we are still gonna use this formula, but we will use it in another different method. So in the last video we said we are just talking about a cylindrical member which is just on its own and the force is applied. So we said we cut it and analyze it, but here in this video we will be having two members. We have something like this. We have a cylinder, an open cylinder. Cylinder is like this, and the cylinder is said to be at rest on a metal, said to be at rest. Then a load there is a load here that passes through inside it. I don't know if you understand this, my drawing. I said there is a cylinder is kept on top of a fixed position. Here is fixed and is put on top. Then a rod passes through the cylinder inside of it. Then when it come outside, they started applying a force, in the sense that this is a fixed point, in the sense that from here the rod will try to elongate, to try to extend, then the cylinder will try to compress, to try to come a little bit somewhere. So the cylinder will try to compress here, while the rod will try to elongate here. Note that this sign is called elongation. Yes, while some is called diffraction. So in some question they will ask you find the elongation of so you have to is this, or find the diffraction of it. Is we are talking about this, which we know as this. So here we will try to analyze this. Here let's call this aluminium. And we know that okay, let's say the area of aluminium is given, said to be 1.75, for example, inch squared. And we know that the Young modulus of aluminium is 10.4 times 10 to the 6 psi. Now we call this cylindrical member an aluminium. Here we will try to call this, okay, let's call this rod a steel rod, and let's use a Young modulus of 29 times 10 to the 5 psi. Now we have this cylinder, and we are told it is aluminum. We have the area of it and the young modulus of it. Then we call this rod. We have the young modulus of it. Let's call this B. This place B. We will try to call this A, and we call this C. So now, what are we looking for? We are looking for the elongation. This elongation part of C. So we will say that we are looking for elongation of C. So here in the last video we have just one, which we just have this formula, but here we have two members. We have two of this. So what do? We will try to analyze this one after the other, each by each. You analyze this, each of this, only the cylindrical part. You find the elongation of this cylinder and the elongation of this rod, then add them together. Let's try to do that. Let's try to use this color for aluminium. The force L over A E. This is for aluminium. Let me do it here, sorry. This is a force area over. We say this is for aluminium. And we will try to add it with the elongation of this steel rod. And we said this is force rent area of E. Steel rod. Now, I hope so far is clear. In the previous video we said we have just one member, which we will use just one formula like this. But when you have two members, we can even have three members. You will try to analyze it one after the other. One, use the formula to solve for each of the members. Now we have this. We found this. We have to find the force, the rent, the area, and the young modulus of this aluminium, and also this for this steel rod. Now we are looking for this XC. Now here we were told that let's take the length from here to here. Let's say the length is 4 feet, and the length from here to here, let's say it's 3 feet. Okay, now this is P. This is P, and we know that, let's say that P is 15 times 10 to the 3 LB. Now we have everything. We will be given the force, we will be given the distance, we will be given the young modulus of the members. Now that we have everything, we will try to solve this. When you look at this force will try to we try to stretch this member, and the same force will try to compress this member as well. So here we will know, we already know the force. We are going to use the same force for these two. Now let's put in our values. This is a little bit easier if you understand the concept of this diagram. It's a little bit easier for you. Then here we said our force is here, which is 15. Said our force is here, which is 15 times 10 to the 3 lb multiplied by length. This red color here, I told you is the length is this cylindrical member. So we will try to solve this, and we are looking for the length. We will try to use the length of the cylinder. So this cylinder we have 4 feet, and here feet will not multiply, will not go with this force here. The feet we have here will not go with this force lb. We will try to convert it to inch. So here we know that feet, if feet, for example 4 feet, for example, if we have 4 feet here, we will try to multiply it by 12 to have it in inch. So 1 feet is this one now, this 4 feet now, 4 times 12, we find it in inch here. If we multiply 4, the given value of it, if we multiply it by 12, we will have it in inch. All over the area. Okay, we don't need to solve for the area of cylinder up here, because the area here is given. We have the area here. So the area is said to be 1.75 inch squared over here. So that is the area is given, as we see it here. The area is given, so we put the area times the Young modulus. If you look up here, you will see the Young modulus is given as well. So we will put the Young modulus 10.4 times 10 to the 6 lb inch squared. So this one, this values is this. Then we will add it. We will add it with this one as well. So what you did here, we have to do it as well here. So here force, we are using the same force that compress this and extend this. One force is applied. So here we are using the same force as 15 times 10 to the 3 in lb multiplied by length. Here now we have this length. In the first one here, we have just the length of the cylinder, which is here. But here in the second one, we have the length of the steel rod, which is here from the beginning of this place to this place. So we will try to add these two values. 4 plus 3 is 7. So we can't leave it in. We found 7 feet. So we can't leave it in feet. We will try to convert it to inch by multiplying it by 12. So we say 7 times 12, which will give us an inch. Okay, now the area, this is a cylindrical rod. We know this is cylindrical rod. So we know the area of a cylinder. We say this pi d squared over 4. This formula is the area of the cylinder, area of a cylinder. So diameter here is said to be given. Diameter here is said to be given. Diameter of this rod is said to be given. Let's say 5/8 inch, 5/8 inch squared. So here we have the diameter. We have to multiply it, do it diameter raised to power 2. So here we will put the values, the diameter, which is pi over 4. Diameter is 5/8 to the 2 in inch squared. Okay, the area multiplied by the Young modulus, which is given here, which is 29 times 10 to the 5 lb over inch squared, So now we've analyzed the both. We've analyzed this and this as well. So now we've analyzed this cylinder and this rod, and we found our values this place. So what do we do now? We have to calculate everything. This, calculate this, plus calculate this. Let me try to run faster bit. 15 times, it's gonna take a little long time, but let me try to do it faster. To the 3, 15 times 10 to the 3. Okay. Okay, add it with this one. Okay, 1 or 2 things. Okay, here we found this C equals to 0.049 inch. As I told you in the previous video, this is always 0 point something. If you found anything that is more than 1, that means you have to check yourself. So it must be 0 point something. So now we found this. The idea here, when you have two members working on the same distance, you just have to find it. Normally is when you have this, we call this A, call this B, and we call this C. So since we have A here, B here, and C here, we will say that let me write it here. We say that X, this C, is equals to here. This from A to B, the cylindrical part of it that we calculated. So we said is this AB, deformation of A, B plus the rod which we calculated, the steel rod, plus the deformation of B, C. This is exactly what we did here. So we said this is this, so this and this also, the two members we analyzed together to find this. So this one is AB, with this one, the aluminum part of it is AB, this, and the steel part of it, the steel rod is here from B to C. So the steel rod is here, is B, C. So this is the idea. In this chapter 2 there are more questions. Like I don't have much time, but let me try to give you one question, so you will try this. If you can be able to solve this question, maybe in the next video we will try to solve the question, but just take this as your homework. Here, when we have a cable, this is a cable, and the cable is fixed here, and diameter of the cable, let's say the diameter is 4 mm diameter here, and steel cable, which the Young modulus of the cable is said to be 200 gigapascal. This, and the cable is fixed here, and the force is now applied somewhere here. It's tricky though. We've not solved this type of question where the force is applied not on the member that we are looking for. The other ones we solved, this is the force is applied here, and we are looking for the elongation part somewhere here. But here now we are looking for the elongation of the cable, and the force is applied not on the cable but somewhere. So you'll try to solve this. In the next video I will try to talk a little more on it. The distance is 3.5 meters, and this is 2.5 meters. Then the distance from here to here is let's say 4 meters. Okay, now you try to solve this. You first of all you have to find P for like this. Okay, let's do this. The stress is given, let's say the stress is given as 190 megapascal. The elongation we are looking for is, okay, use this as your homework, solve it. In the next video we will try to solve using another method where the elongation that we are looking for, something like this, will be given. When it's given to you, the stress will be given to you. There's what we call even this P. Maybe if this is given to you, we will try to solve for P. So try this at home. Try to solve for the elongation on the cable. Know that our idea, first of all, you have to cut it to find the force on the cable, and you analyze it, you have everything. So see you in the next video. Thank you for watching.